Welcome to True Projects. In this video, we are going to explain about a project titled Image Denoise Removal Using Deep Learning. Image denoise removal is an influential technique within the realm of deep learning. Has proven its capacity to significantly enhance the image quality by addressing the noise contamination. Capitalizing on the capability of the artificial neural network, particularly the autoencoders, this method adaptively suppresses the unwanted noise while safeguarding the vital image feature. The process involves training the network on a diverse dataset containing both the noisy and the clean images, enabling it to proficiently reconstruct the denoised version of the input image. This powerful fusion of the deep learning and the image denoise removal is opening the new avenue of applications in the various fields, and such as computer vision and the medical imaging. The outcomes are revolutionary, offering us sharper, clearer visual in our expanding digital world, transforming the we perceive and utilize the visual data. And the primary goal of implementing the autoencoder algorithm is to achieve the efficient unsupervised learning of the feature and the data compression. This algorithm utilizes a specialized neural network architecture comprising an encoder and a decoder to learn a concise and a significant representation of the input data in a lower dimensional space. During the training, the autoencoder iteratively minimizes the reconstruction error, ensuring that the decoder can accurately recreate the original input from its compressed representation. This remarkable ability enables the autoencoders to excel in diverse tasks, including the image denoising, dimensionality reduction, anomaly detection, and the feature extraction. As a result, the autoencoders have sparked the groundbreaking advancement in the computer vision, natural language processing, and the data analysis, propelling these fields into the new frontiers of exploration and the innovation. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7 or Ankunda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, the necessary libraries and frameworks required to build and train the deep learning model. Commonly used are TensorFlow for training the neural network, NumPy for numerical operation, Matplotlib for visualization, and Flask for building the web application. And the second one is importing the dataset. Here the dataset contains of the various images within it. This dataset will be used to train the autoencoder to remove the noise and denoise the images. The dataset should consist of both the noisy and the clean version of images to enable the model to learn to denoise effectively. And the third one is image processing and scaling. Before feeding the images into the autoencoder, some pre-processing is necessary. This involves resizing, normalization, image processing technique to prepare the data for the training. Scaling the images to be suitable ensures efficient training and reduce the computational overhead. And the fourth one is splitting into the training and the testing. The dataset is divided into the two parts, a training set and a testing set. The training set is used to train the autoencoder model, while the testing set is used to evaluate the model's performance and generalization. And the fifth step is building the model. An autoencoder is a type of neural network that consists of an encoder and a decoder. Encoder takes the input image and compresses it into a lower dimensional representation, while the decoder reconstructs the image from the compressed representation. To minimize the reconstruction error during the training, which ensures that the model learns to effectively denoise the image. And the sixth step is training the model. During this step, the autoencoder is trained on the training dataset. The model learns to encode the noisy input image to a compressed representation and then decode them to reconstruct the clean version. The training process involves feeding the data through the network calculating the reconstruction error, and updating the model's parameter using the backpropagation and optimization technique. And the next step is user gives the input. To provide a user-friendly interface for the denoising image, we use the Flash Web framework. It allows the user to upload their own image to noisy image they want to be denoise. And the next step is the given input is pre-processed for prediction. Once the user submits the input image, it needs to be pre-processed to match the format required by the autoencoder. This includes the resizing and the normalization to ensure the image dimension and the values assigned with the model input. And the next step is trained model is used for the prediction. The pre-processed input image is then passed through the trained autoencoder model. The model will denoise the image, removing the unwanted noise and preserving the essential features. And the last one is final outcome is displayed. Finally, the denoised image is presented to the user through the web application. The user can see the comparison between the noisy input and the denoised output, highlighting the effectiveness of the image denoise removal using the deep learning. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various images folders within it. The static folder containing of the various folders like JavaScript, CSS, images, bootstrap files and uploads within it. And the template folder contains of the HTML documents that are used in this project. It typically includes the files like index, home, after, notebook, sign in and sign up pages within it. And the test folder containing of the images that will be used for testing the performance of the model. And the trained model contains of various images that will be used for training the model. And the train cleaned model is after the pre-processing of the images. App is an py file which contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user requests, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains a combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And the overall code is present in the file of IPYNB named notebook contains as the combination of images, codes and graphs within it. And to execute the project, we build a Flash framework as our front end. And for the execution, first we need to copy the code folder path and then open the Anaconda prompt. Here first we need to change the location of the disk to F because our code folder is present in F disk. And then write a command cd space and paste this code folder path. By this, it will change the directory to the current code folder path. And then click on enter button. We need to write another command, this python space app.py. By using this command, it will execute the Python script and perform a runtime check for any syntax errors or the logical issues. And then click on enter button. After running this app.py file, the Flash framework will host the application locally at the default local address like this. And we need to copy this local link and paste it on any of the web browser of our choice and prefer to use of Google Chrome. And I'm clicking on this and here we redirect it to the home page containing of the title and the sign up buttons of it. And here click on the sign up button. Here we redirect it to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it redirects to the sign in page Here it contains the username and password and need not to be filled, as of username with admin and of password too. And then click on the sign in button. Sorry, it's of wrong step. I think so. And click on sign in button. Here we redirected to this index page containing of the choose file and upload buttons. Here click on the choose file button. Here we redirected to the test folder containing of images within it and selecting the one image and click on open button. Here and then click on the upload button. Here it redirected to the result page and predicted the result as of the given input image and its of the data within it. And this way we can denoise the image, and by clicking on try again button, choosing we redirect back to the index file, and here we can choose the file, click on choose file and click on any image and click on open button and then click on upload button. We'll redirect it to the result page, and here the image we uploaded and here the denoising the data that is present in that image. And this way we can denoise the image by using the deep learning autoencoder model. And in conclusion, the autoencoder algorithm proves to be a versatile and powerful tool in the realm of the deep learning. Its ability to learn the unsupervised feature representation and efficiently compress the data opens up the new possibility for the various applications. By leveraging its neural network architecture, the autoencoder excels in the tasks like image denoising, anomaly detection, and the feature extraction. Its widespread adoption has revolutionized the field, such as computer vision, natural language processing, and the data analysis, enabling the sharper visual, improved data representation, and enhanced decision-making capability. As research and advancement in the deep learning continues, the autoencoder impact is bound to grow, further enriching the potential of artificial intelligence and the machine learning.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.